Hello, this is the Team 3 demo. Team 3 includes myself, Ashley Fillmore, Michael O'Reilly, and Stephen Squire. What you can see here is our website landing page. We did a play on Airbnb. We have it called Our BNB. So when a user first logs on to this website, they will be brought to this landing page, which is for the login. This was built using React, Java Springboot, MySQL, and AWS. So let's begin by going to the register page, and we can register a new user. A user can pick any username they'd like as a string, a person ID as an integer, and also a password, confirmed password as a string. It can be as long as short as they would like. We register, which automatically brings you back to the login page. And then we can then log in using the username and password that was just created. This now brings you to the search page. You are able to search by location, province, city, and street, and you can also search by rental type. So we can provide an example using province. We'll use Quebec, and then this will show the results page. Surround yourself with nature would be the description of that particular B&B, with availability, rental type, rating, nightly rate, and renting since the date that it was rented. We can also search by city, street, and as well as rental type. So this is our website. It is highly scalable as well. So I'm now going to pass it on to Michael, who is going to discuss the AWS portion.
Thank you, Ashley. So within AWS, the first thing we had to do was instantiate an RDS database using MySQL. Go into our database. Under connectivity and security, some things to note here are the endpoint, which we had to use to connect my workbench and the MySQL database. Under the configuration setting, you can take note that we had to use our username and password to make it accessible and also to protect our data. From here, we will navigate to Elastic Beanstalk. Some things to note here are that we had to initially deploy this project locally using MySQL and Postman. And then once we navigated to AWS, we used Elastic Beanstalk. From here, we created an application which automatically generated our environment for us to upload our jar file. This is where we uploaded our RESTful API to communicate our application and our database. From here, we can navigate to the configurations tab. We can see that our software, we're using Gradle M2 Home, and that allowed us to use the Maven project management software. Within security, we had to ensure we changed some settings here to allow access for our IAM roles. Now we'll navigate to S3, which is Simple Storage Service. From here, we had to create a bucket, which would host our static React project. Once we navigate to the permissions tab, you can take note that we had to create a bucket policy, which allowed access in and out of the bucket. Back in the properties tab, you can see that our website is statically hosted on S3. And once you click on the link, that will bring you back to our website. From here, Stephen will walk through the demo of our code, front and back end. Over to you, Stephen.
Thanks, Mike. I'll start with our front end code. So we built this in React using a template of a past React project to do similar API work with different databases. Starting with the components, we've got a header and a footer coded to be static to all of our pages. Inside the header, we've got a nav bar that features a ternary operated toggle switch button that switches from saying log in to log out based on the state of the page. And our footer just uniformly says a little thing about how we coded it and who coded the project. In our pages, we've got our splash page, the login page, set up to have navigation, stateful management, and some hooks to ensure proper logging out on returning to the login page, as well as launching our fetch request to the API hosted on Elastic Beanstalk for user verification on login. This page has a link to the register page, as shown in our demo earlier. Similar setup of stateful management and hooks, as well as a template of the user object that we're pulling from the database, which we can send up via this post request to the database. And that one is there. The search page also has stateful management and navigation features, and launches a query to the API using the radio button selection, as well as the search value taken from our HTML as noted here. And then our results get rendered inside a toggle here that only displays when there are results. The results, similar dependency stack as other pages. We place the results inside a short results from the props, and then map that through a for each, displaying each of the results in a formatted and styled manner from within the search page. Our CSS for this project was a collaborative effort with all hands styling various pieces, very minimalistic with just some pops of color and some more interesting fonts than the default. Was a style that we all agreed on. And once these things were in order, we had to run a build to generate minified versions of all of our code base, as well as an index.html that we could target from within the S3 bucket. Onto our backend, we've got main and test files within the main. The core of our REST API would start with just the application, which runs the app. And then each of our entities are set up as entities in the persistence engine, with IDs generated sequentially and the other attributes existing as private values, as well as the necessary constructors and setters and getters. Very similar assembly for each of these. They're also all paired with a repository, which defines the types of interactions we can perform on the database for each one of these entities. And as well, we had to write a controller that defines each of the endpoints that we can hit on our API server to pull out information. So we've got one for finding users in the login, adding users via the register, and then one for each of the 4 types of search currently active in our search page. These are cross-origin tagged to allow the data to go from the database through the Java API and into the React app without incident. And we used get and post mappings to achieve the functionality showcased today. In our testing, we ran tests on all of our entities, getter and setter methods, to ensure consistent results, as well as all of our repositories, intended routes, using mocking to simulate database data returning, just to ensure that we had the necessary methods to functionally run this app. We also had to do work in our application.properties to properly target our RDS instance on AWS and log into it. And we had to build a jar file that we uploaded to Elastic Beanstalk, as mentioned in the AWS, using the Maven commands clean and install once our project was in a functional state. And that about sums up the code base for this project. Thanks for listening to our demo. It's been a pleasure working with Michael and Ashley this past 2-week sprint.
That's great. Thanks, Stephen.
Thanks, guys.